It wants you to find the x and the y-intercepts and then graph each line. For x-intercept, you are zeroing out your y. You're zeroing out your y. So it's always going to be whatever your x is plus 0 equals that. It's always going to end up being this c value here, remember it's in standard form, over the value that's in front of your x. In this case, looks just like that, all right? Because your y is zeroing out, so you're just end up dividing by the coefficient. In this case, it was a 1. Your y-intercept then just does the opposite. It's going to zero out your x. So you're saying 0 plus that 2y equals -4. It's always going to end up being that constant over the number that was in front of your y, in this case 2. So it reduces to -2. Those are your intercepts, okay? Your x-intercept, you graph on the x-axis. -4 on the x-axis is right here. Your y-intercept, you graph on the y-axis. -2 is right here. And then you connect the dots. Once you have your 2 points to graph it, you literally just connect the dots. So once you have any 2 points, you can connect the dots. It helps to actually. And then it goes on infinitely, which is why we have the arrows on the end. That answers all parts. X-intercept, y-intercept graph. At this point, we get into questions about slope. All right, I can ask for slope a couple ways. The first way is I can give you a graph. I actually chose the first and the second one here because the first one is a special case. If it is a vertical line, your slope is going to be undefined. All right, because your numerator represents how far up and down you go. In this case, I go up 1. And your denominator represents how far left and right I go. In this case, I go nothing left and right. Anytime I divide by a 0, I get undefined. So when it is a vertical line, you actually don't even have to do that. You can just say undefined. If it is horizontal, horizontal lines will always have a slope of 0. All right, so those are special cases. So I pulled this one because it's a special case. All right, a vertical line is an undefined slope, so that's this answer. If it had been a horizontal line, it would have been a slope of 0. For any other line, you're going to have some positive or negative number. If it looks like this, going up from left to right, it's going to be a positive number. If it's going down from left to right, it's going to be a negative number. And when you're given the picture or the graph, you can literally just start at the left point and walk to the next one. How do I walk? Well, for this one, I'm walking up 1, 2, 3, 4. So my numerator is that one, 4. I'm walking right, 1, 2, 3, 4. So my denominator is 4. Always reduce them if it's able to be reduced. So my slope here is 1, positive 1. The next set of questions also ask for slope, but it gives you sets of points. So this is where we're going to use our slope formula. The number one problem I see with slope formula is messing up your positives and negatives. First thing is, what is the slope formula? Well, the slope formula is that I subtract my y's, that's my numerator, and I subtract my x's, that is my denominator. All right? It is subtraction here, so pay attention. And it doesn't matter which group is 1 or which group is 2, as long as you do it in the same order. So if I say that this is group 1, this is group 2, then I need to make sure that I follow the order that I start in. y2, that's -1, minus y1, that's -13, over x2, that's 2, minus x1, that's -5. You do have to apply your rules of subtraction. When I say minus a negative, that is adding a positive. So -1 plus 13 is positive 12. On the bottom, I have the same thing. 2 minus a negative, that is plus a positive. So 2 plus 5 is 7. You leave it as a fraction. I do not want a mixed number. That cannot be reduced. 12 and 5 don't, or 12 and 7 rather don't reduce. So that is my answer, 12 over 7. So this is the same thing here. Slope-intercept form of the line. Once again, y equals mx plus b, and I am filling in my m and my b. And in this case, they gave me my m and my b. My slope, that is your m. Y-intercept, that is your b. When they give this to you, you literally just write it. You're going to say y equals m. That's that guy right here. Negative 5/3 x plus b. That's positive 5. That is my answer. I am done with that question. So writing equations of lines, it can give it to you multiple ways. It can ask for it different ways. In this case, it wants you to write the slope-intercept form of the line. So when it says write the slope-intercept form, your answer is going to be in this form. And you will fill in the m and the b. Over and over, that's what you're going to be doing over the next few pages, okay? They're just going to give you different things. So this is identical to the page before, but they didn't give me everything the same, all right? They gave me this equation, but they gave it to me in standard form, and they want it in slope-intercept form, all right? So again, I'm going to write it in y equals mx plus b, and all I'm going to have filled in is the m and the b. I'm still going to have an x and a y, but really all I have to do is move things around. When they give it to me in this form, I'm going to move my x over. I'm going to leave this alone for right now, so I'm going to say negative 3y equals, remember when I move it over it changes signs, negative 2x minus 19. And then I need to divide every single piece by that number that is in front of my y. So now on the left-hand side, I have the y by itself. Negative 2 over negative 3, that's positive 2/3 x, that's my m. Negative 19 over negative 3 does not reduce, but it does change to positive 19 over 3. That's my b, and I am done. Put this in slope-intercept form, but they've just given me different pieces. They've now given me some point and the slope. There are two ways to do this one. You can use your y equals mx plus b, or some of you prefer the point slope. That's y minus your y value equals m x minus your x value. All right, we're going to do this both ways. If you use the first one, then you're going to say, I have my x, I have my y, I have my m. I need to solve for my b. So I'm going to plug those in. I'm going to say y equals m times x plus b. And then I'm just going to use algebra to solve. Remember 1 over 6 times 4. 1 over 6 times 4 over 1. That's 4 over 6 reduces to 2/3. All right, so make sure you do that multiplication correctly. 2/3 plus b. To solve for b, I'm going to subtract 2/3 from both sides. Cancels here. Remember, when I'm subtracting 3 and 2/3, I need a common denominator. That common denominator is 3. So I multiply the top and bottom by 3. So I can change this 3 to 9/3. 9/3. So I have 9/3 minus 2/3. That's 7/3. All I have done at this point is solve for b. I still need to write the slope-intercept form, which means I need to write y equals m. They gave that to me, 1/6 x plus my b, which I just solved for, 7/3. All right? That is the first way to do it, using slope-intercept. You may also use point slope. Some of you preferred that, it looked like, on your quizzes. So if you want to do point slope, you're going to do the same thing. You're just going to use this equation. You're going to say y minus your y value, which was 3, equals m, that's your slope, x minus your x value, which was 4. All right? For this way, all you need to do is distribute and then move that y over. So we're going to say y minus 3 equals 1/6 x. Again, 1/6 times 4 gave me 2/3. It's a positive times a negative. That is negative 2/3. Then I'm going to add my 3 over. Remember, 3 was 9/3. Y equals 1/6 x plus 7/3. As you can see, you get the same exact answer whether you do the first way, just solving for b and then plugging it in, or whether you do the second way, just plug in your x, y, and m, and then get y by itself. You get the same answer either way. So it's asking us to write the slope-intercept form of the equation, but now it's given us something else. It's given us 2 points. In order to write the slope-intercept, I need y, I need m, and I need b. I don't have either. So the first thing I'm going to do is I'm going to solve for m. Technically, I have b on this one, but we'll talk about that in a second. So I'm going to go back to that slope equation that I've already used on this test review. All right? And I'm going to say, well, I need to subtract my y's. I need to subtract my x's. So I have y2 minus my y1, x2 minus my x1. 3 minus a negative 3, that's plus a positive, that's 6. 0 minus a negative 3, that's plus a positive over 3. 6 over 3 reduces to 2. I have the m piece that I need. I need my b. I can do it one of 2 ways. I can either use y equals mx plus b, or I can use y minus y1 equals m times x minus x1. All right? Here's the thing. It doesn't matter which point you use. For either one of those, you will get the same answer. You'll get the same b, and you will get the same equation when you're all done. All right? I will say this one in particular, of the 2 points, one of them should look familiar. All right? Anytime they have this, what is that? My x is 0. What is that point specifically? Yeah, it's the y-intercept, right? When my x is 0, I have found my y-intercept. I did that on the first page. So actually, I already have my b on this one. This particular one actually gave me my b. Not all of these do. In fact, of all 4 of those questions, this is the only one that gave you the y-intercept. But if you recognize it, you can go straight from here to my answer, y equals mx plus b. If you don't recognize it, you're going to have to do what we did on the prior page. You're going to have to plug it in. Or if they don't give it to you, you're going to have to plug it in here and solve for b, and then plug in your m and b, or plug one of those in here and solve for y to get your slope-intercept. But from this point forward, you're doing exactly what we've done for 3 or 4 questions. All right, for this one, we are going to sketch the graph. I actually chose this one specifically because you go off the graph one way or the other, depending on which way you do it. So when it is in slope-intercept form, you always want to start at your b. Your b, remember, is your y-intercept. So that will always be the point on the y-axis where you start. So I'm going to start at positive 5 on my y-axis. My slope tells me how to move. Now my slope is negative 5/4. That can be a negative 5 over a positive 4, or it can be a positive 5 over a negative 4. All right? So the reason I write that is sometimes going up and right is going to take you off, and sometimes going down and left will take you off the graph. So I always choose whichever one keeps me on the graph. All right? In this case, if I went up 5 and left 4, I would be off the graph. So I'm actually going to move using this first way. So I'm going to go down 5, which is 1, 2, 3, 4, 5, takes me all the way to the 0. And then I am going to go right 4, 1, 2, 3, 4. All right, so for a negative slope, only one of my movements is negative. Only one of my movements is negative. So that's where my second point is going to be. And then once I have 2 points, I'm just going to connect those dots. All right, so use some straight edge, connect your dots, go a little past them, and put your arrows on either end. That is your graph. Had it been a positive slope, so if you look at number 32, a positive slope, that slope was 1/4. That can be +1 over +4 or -1 over -4, okay? So 2 positive movements or 2 negative movements would be a positive slope. Again, I use that just in case going up and right takes me off the graph. Then I might go down and left, right? Which is still a positive slope. All right, these will not be separated on your test. It will be just like your quiz where parallel and perpendicular are in the same group of questions. So you have to pay attention to what it's asking you, all right? For parallel and perpendicular, I only care about the slope. So this line that they give me, I do not care about that B, that plus or minus at all. They want a line that goes through this point and parallel to this line. You can go ahead and just scratch that guy out. He has nothing to do with what you're about to do in this process, okay? You do not need the B from the parallel line. Parallel lines have the same slope. So all I need from this is what the slope is. That is my M for this problem, all right? So once again, they want the slope-intercept form of the equation, which means I have to have the M and the B. I can look at the other line and I now know what my M is. Then I do the process exactly the same. I can either use my y equals mx plus b or my y minus y1 equals m times x minus x1. You can use either one of those to figure out what your equation is. If you use this, remember, you are only using this to solve for B. You are not done, okay? If you use this one, once you get y by itself, you are done, okay? So it just depends on which one you want to do. If I use the point slope, I would say y minus my y value, that's 5, equals m. That I found from that equation they gave me, 9/2. X minus my x value. My x value here is -1, all right? So that's using point slope. Before you do anything here, simplify that minus minus, okay? Minus minus is the same thing as saying plus. Some of you messed up your positives and negatives because you left it a minus minus. So this is the same thing as that, all right? Then I'm just distributing and moving that 5 over. So distribute your 9/2. You get y minus 5 equals 9/2 x plus 9/2. And then we are adding this 5. Remember, it's 5 over 1. I need a common denominator, which is that 2. So 5 over 1 is the same thing as 10 over 2, right? 10 over 2 equals 5. So that's the same thing there. So I have canceled the 5 out there. My y is by myself. 9/2 x, that doesn't change. And then I have 9/2 plus 10/2, that's 19/2. If I cannot simplify it, that is my answer. I'm done. So this is if you use point slope. Let's say we're going to use our y equals mx plus b the whole time, which is fine. So I'm going to say, use this y value, that's 5, equals m, still going to use that 9/2, x, that's my -1, plus b, all right? So then I just multiply positive 9/2 and a -1, that gives me -9/2 plus b. To solve for b, I'm going to add my 9/2 to both sides. So now I have 5 plus 9/2. Once again, that's 5 over 1. We have to get a common denominator, which is 10 over 2. So I have 10 over 2 plus 9 over 2. B is going to equal 19 over 2. I'm not done, though, when I do it this way. I need to rewrite the whole thing. Y equals m. That's that guy right there, 9/2. X plus the b that I just solved for, 19 over 2. And that is the same answer as what I did with point slope. So this now wants a point that goes, a line that goes through the point -1, 3 and perpendicular. You can once again just cross this guy out. The plus or minus of that line does not matter. I need to figure out what my slope is. Now on parallel, I would have used -1/2, exactly what the slope is. But for perpendicular, my slope is going to do something different. I'm going to take this 1/2 and I'm going to flip it. It's going to be 2/1 instead of 1/2. And whatever this is, I'm going to change it to the opposite. This was a negative. It's going to become a positive, all right? Now, 2/1, what's an easier way to write that? Just 2, okay? So don't use 2/1. It's going to make your life more difficult. Just use +2. So for perpendicular lines, I need to flip and negate. Then I am going to do exactly what I did on the prior page. I'm either going to use the y = mx plus b to solve for b and plug it in, or I'm going to use y minus y1 = mx minus x1 and then just solve for y. Okay? Identical. Whichever way you choose, y minus my y1 equals mx minus my x1. It's going to give you the same answer no matter how you do it. Distribute. And then add my 3 over. All right? Or if you want to solve for b, you can say y, that's 3, equals mx plus b. 3 equals -2 plus b. b is going to equal 5. Go back, plug it back in, y equals mx plus b. Both ways give you the same answer. All right. So I actually gave this in 2 ways. The first way, it's already in slope-intercept form. You're going to graph it identically to the slope-intercept form that we just did. All right. So I'm going to start at my -3. In this case, -8/5 will move me off. So I am going to use a +8 over -5. All right. Either one can be negative. So I'm going to go up 8. And then I'm going to go left 5. Up 8 and left 5 to get my second point there. Now here's where it changes. Normally for a line, I would just draw that line and I would be done. But now I need to actually look at this greater than less than sign. If it's just greater than or less than, my line is dashed. So in this case, this guy is dashed, all right? So that's the first part. I am dashing it because it is just less than. And then which way do I shade? Well, my y is smaller than this line. So I'm going to go to where my y is. This direction makes my y smaller, right? My y is -3. So I'm going to shade the side that has the -4, -5, -6. I'm going to shade that side of my graph. So I'm going to shade this side of my graph here because that's where these y's get smaller. When it is in standard form, I would put it in slope-intercept because it's going. This guy in particular is going to flip your sign. All right. So the first thing I'm going to do here is I'm going to change this to slope-intercept form. All right. I'm going to move that 3x over. I have -y is greater than -3x minus 1. There is something in front of my y. What is it? A -1, which means I need to divide everything by -1. So I get y, because I divided by a negative, that will flip. That's going to be a +3x and a +1. All right, so this is why I put it in slope-intercept form, because it changes some things. But once again, you start at 1. My slope is 3. That's 3/1. Up 3 over 1. I decide, do I have a solid or a dashed line? Once again, this guy is dashed because it is just less than. And we go by my final, not by the original. Okay, so my original said greater than, but we go by what it looks like in slope-intercept. Less than, I'm going to go on my y-axis. I'm at +1. This side of the line is bigger than +1. This side of the line is less than +1. So I am going to shade this side of the line, where that y-axis makes it smaller than +1.